Okay, what's up? We're on our journey to create a robot that raps, makes beats, and does it all. This is going to be a multi-part video series. Yesterday we got Harmonai set up locally so we can have a little more control over what we're doing here. Now let's get some more songs imported and let's try and train this bad boy to spit out that super hot fire. Alright, so before we get started, just the plan is we're going to download a bunch of videos, MP3 style, and we're going to convert those into WAV files. We're going to pass those WAV files through the fine-tuning model, and we're going to train up some music generation. I'm going to start with the Maestro piano player because we need Beethoven on the beat. We need inspirations from Handel. We need our classical inspirations for this, and the other options, there isn't really a rap one that I saw, but we'll figure it out, so that's way down the line. First thing we're going to do right now though is run the local Harmonai setup, the local dance diffusion, make sure everything works. Okay, so let's generate a sample from a piece of audio. We're going to go to this online audio converter. Very easy to use. I'm going to put the quality up to extra high. I've put the quality to CD quality, and this is what it sounded like.
See, we flashing crashes a hobby. Been going too fast with this shit, something like Ricky Bobby. I'm strapped like it's part of my body. Stiff at the shoulders, I'm something like Fraser Ali. You fake it, you niggas a copy. I bet if I give her this pill that she jump out of body. It's wet, but I bet it get sloppy. Cause I got a stroke, give her hope, and I bet he can't copy. What's cold on that field was a jockey, but I had been
My goodness, I mean, Shakespeare, he never could articulate emotion in such a way, you know. Anyway, so that was CD quality. Let's try extra high quality. Super easy, just open the file, go to the folder where everything is, and let's open that MP3. It's going to convert, and we're going to download that, and we're going to show in downloads here. That's the first one. We're going to move it to the desktop folder called Rap WAVs here, and we're going to go into that folder, Rap WAVs, and we're going to rename this to something a little more reasonable, Big X the plug underscore safe house. And there we go. So we got that in there. Now we go back to the VS Code. We enter the file path by making sure to set record audio to false. If you set that to true, it'll open up a nice little GUI for you to record and download audio. Keep that at false, and it will ask you to enter a file path. Or you can keep it to false and enter the file path here, and it'll have the same effect. So let's go back to where we were, and we can open in terminal here, type in pwd, and we can copy this with Control-Shift-C and Control-Shift-V, and we then forgot to type in Big X the plug underscore safe house dot wav, and that should be the same name, Big X the plug underscore safe house dot wav. So we're good to go. Hit enter, and this is it's going to plot the audio signal. So just exit out of that, let it do its thing. Okay. And that is all of the regenerated samples. So we exit out of that. And here it'll tell you where everything was saved. We also have this weights and bias project overview. It gives some information that may or may not be useful. Anyway, so that's that. Then we go to the audio out, which is where I specified these to be saved in the output directory, and the output directory name here, I added this date time here so that every iteration will have a different name for each run. So we go to the audio out, and we can see that we have the Big X the plug for 8 seconds because the sample length multiplier multiplies the initial 4-second clip by however many you put in here. 8 is fine. We start running out of memory around 32 seconds, so around 8. When the multiplier is up to around 8, you start losing memory on my machine, which okay, so it kind of just preserves the beat from what I can tell. I've had way better generations than that. You can exit out of that, and that's just running it simple. You can also run the raw, generate raw, and this will generate, that's actually what was open. I was running the generate from audio, which is the same thing, except it takes in the audio file. The generate raw just generates raw resamples of the Maestro. So it's very similar to the Maestro set. And that's all you got to do for just running it. Next, there is the interpolation and the fine-tuning, so we can start training. Alright, so we're running about 5 gigabytes with the sample multiplier at 1, so we're only getting 4-second samples, 100 steps. Not too bad. The last output interpolated.
Carbons and rockets, they spin when I spin, pull up, drop off the pop. All big bodies with shotties, carbons and rockets. They spin when I spin, pull up, drop off the pop. All big bodies with shotties, carbons and rockets. They spin when I spin, pull up, drop off the pop. All big bodies with shotties, carbons and rockets. They spin when I spin, pull up, drop off the pop. All big bodies with shotties, carbons and rockets. They spin when I spin, pull up, drop off the pop. All big bodies with shotties.
So this is without any fine tuning. This is just using the same denoising algorithm that it used to make classical music. Or not, I don't know if it's classical music, but piano renditions. Okay, so we got through one epoch, then we ran out of memory. Alright, so it looks like everything in fine-tune is working. I forgot to specify this as a string. We have a random crop string, so random crop is now set to true. Alright, what is up? It's another beautiful Saturday morning. I don't know what I'm going to do today, except post some videos. I'm not sure how many videos I'm going to post, but as you can see, this bad boy's running hard. We're at around 7. Because I got the CPU on my integrated graphics, that's my theory. Any additional CPU work all of these things are getting run on the CPU. All of the graphical outputs, the monitoring, handling of the applications and things like that. The opening and closing of windows, all that's on the CPU, and I think it's just a little too much. The workers are also on the CPU, so a little too much workload on the CPU. But we ran through about, let's just say 1600 epochs. Ran through, we started, and I need to fix the naming scheme because although this will be unique, it's hard to see which order these are supposed to be. 190,001 is the first one, and the second one is 250,001. So that's weird. And then it goes back to 19 at the end. So we started out with this. We progressed to the second one just to show that it gets kind of weird. And then we get here. So, yeah, it's definitely hasn't produced anything of quality, but that's definitely a result of the poor data that I used as input. Just wanted to get something out there. So the initial audio is actually mostly a heavy dub.
At Eloise Park in 1944, Garvey said, 1977, I go well dread, y'all. Tell it to your black brothers and sisters. When you 27
So that's an hour, and everything else is, we got a couple rap songs in there. You've heard these all before. But then there's also or AI generated pieces of noise, I think is what we're gonna have to call these. So that's not, you don't want to mix the dirty and the clean. You know what I'm saying? That's that. I'm just happy it's running, basically. I let it run all overnight. The settings that I used. Okay, so we start here with the fine tune. Things that are important are the sample size has to be a multiple of 18 of 8192. Be a multiple of 8,192. 8,100s, 910s, 2 1s. That's how I'm going to read numbers from now on. So I stuck with the sample size of 20,000s, 24,000s, 500s, 710s, and 6 1s. With a sample rate of 48,000 and checkpoint every 500 and demo every 250 10s. So I kept the accumulated batches at 4. The issue was having too many things open and using the integrated graphics. I don't want to switch over to not using the integrated graphics because I do want to keep the GPUs free. When I go to the NVIDIA-SMI regular, I am seeing these Xorgs, which are supposed to be the window managers, running on every single GPU, and presumably as well on the CPU integrated graphics. That's gotta be a redundancy and completely unnecessary. So I think that covers everything. Then we're kind of obligated to check out Jukebox before we go back to the text generation. So we'll open up Jukebox, OpenAI's implementation of this that doesn't use diffusion. It's a convolutional neural network. So yeah, just happy it's working. It's gonna work for you too, and if it doesn't, post in the comments. Let me know. Have a great day. Peace.